Well, hi, good morning, and thanks so much for joining me here in my shop on another gray. Oh my gosh, fall has come. It's gray, it's rainy, it's cold. Poor cats. So, what's going to happen to this radio next? So, my intention was to do the alignment, do a preliminary first time through alignment on it today, and really find out how well it works, and I may very well get there. I'm sure I'm going to get there. But first, I found some more capacitors. Oh my gosh. So I was getting ready to hook up my meter here so I could measure the ABC voltage. I was going to put it on the top of the volume control when into view came two more capacitors. Oh my gosh. What's going on with this one? I see something there. Now that piece looks awfully reminiscent of something. I think I've probably thrown it away now. That reminds me, I'm just trying to dig it up here. Maybe I threw it out already. That reminds me of the capacitor with the end that came off. That looks like a capacitor end right here. What is going on? It looks like the internal part from a capacitor. That's what it looks like anyway. Why is this so stiff? This is stiff like a... Something special about this? What's the story on this? It's... Let's get it. See if I can pry it up here. So the wire here is actually coming up through a hole in the chassis from below, and it's coming up here to the center post of the... Oh my gosh, this is conveying all the audio. This thing here, and I don't know what's going on the end here. Well, I'm going to replace that for sure. Now they've got it slammed down on the body of on the chassis here, flat, very... You know what I'm seeing? I think I'm seeing, when I look down here very carefully, it's quite visible in the camera here. Let me just get a pointer. I need a pointer. Give me a pointer. So there's the screw that's holding this bracket here. But underneath it is another bracket, and you can see the edge of it coming here, swinging out. I think this is a metal tube. And this is a capacitor inside the metal tube. This is a shield on there. There's some words written on it here. Well, right away I'm off into some place I never expected I'd be. This radio, well, it's got something written on it there. So how do you replace that? And this one looks replaced too because of the way it's soldered right here. It's the style I use, the technique I use. Right? Don't try to remelt this hunk of solder on the chassis. And just for fun, they got a resistor here too. I'm not too worried about that. So you slide the capacitor up inside. What if I just forget all of that? I mean, obviously they took the time to do this for a reason, and obviously it's to shield the wire inside. Now, even though this wire is not shielded, but I bet you it's shielded just below here, and the other end just goes up to the volume control. And one part, well, the outside of the volume control goes to the chassis here, straight with a bare wire, and the other wire is not shielded. Or is it? I think I can see where the shield of this wire is soldered to the chassis right here. So they're making sure it's shielded under the chassis. Above, they're not so worried. But this capacitor in particular, they wanted to shield that with this kind of metal arrangement. I think if I forego this, I'm probably running the risk of some noise. But look at this wire here, this big long wire here. Why if I just put the capacitor straight from here, down to here, and basically eliminate this piece of wire, aren't I eliminating a pickup point? Why the capacitor but not the wire? Shielding. Then we have this capacitor, goes down to the chassis, the other end of it. Oh, that's tricky to see it. The other end of it actually goes to this terminal. And then it picks up this resistor. So this is and then there's a capacitor up here going across to the input part of the volume control. So you could think of this as leaking some trouble through here, I think, onto the tab. And what would you think of this? This is a resistor capacitor filter arrangement. And it's going to bother my brain to think it through too much. So this guy's probably okay. This one's probably not. This would be where all the funniness is coming when I work the volume control and the AVC voltage, or it sounds like the AVC voltage is kind of wandering around on its own. So what I'm thinking about is, what do I do about that? I push this one out, then do that screw, run the risk of messing up the front of the radio here somehow. Undo the screw, slide out the funny bracket, the tube, push the capacitor out. I think this capacitor is, I don't think it's slid in, I think it's manufactured in there. What are the chances of me being able to push it somewhere? Nil. Well, I can leave it there. I can just leave it all there, put the new capacitor in, shorten up all the leads, everything down to here, and then we can see what happens. What's the concern anyway? Pick up a hum, I guess. I mean, the big transformer's right here, but I'm not sure there's much magnetic, influence outside of the transformer. I don't know. I gotta make a decision here. The alignment is waiting, Jim. The decision is, let's look on the schematic and see, and look at this on the schematic and see what little, and ta-da! Thank you, Jarrett, or Garrett, sorry if I'm pronouncing your name wrong. Thank you for sending me the same schematic, but a much better copy of it where the tubes are not completely blacked out. So let's go take a look at that. Okay, so I still have the camera shot on, but that's okay. That's not really a problem. Let's check this out here. Get a different kind of viewer. 460 kilocycles. Get that in my head, because I think I had 455 in my head. And we can see inside the tubes a little bit. Now what we want to check is the volume control. There it is. Look, this capacitor is shown shielded. And they show the shield. They show the shield of the wire encapsulating the capacitor, which is exactly what's going on down there, essentially. And then here's the ground wire going here. They show this dotted. I think because it may or may not be there, maybe depending upon your radio model. No, I don't think so. This is the one model here. Can't make the image go up and down on the screen. There we go. Volume control, 1 meg, tap at 360 meg, 360. Well, it's got to be K. Well, the M doesn't necessarily mean meg. See, M means 1,000. Meg means 1,000. 1 meg, 350. K is what we would write, but M is what they're writing here. Thank you, France, for that. So there's the value of the capacitor, 0.006. You know, I just don't think this is the biggest issue. I think I can just bypass with the capacitor and not sweat over this. Just zoom it basically from here to here is where it would go. And use the shielded wire from there. And what are my other options? Take the radio half apart and gain what? What are they trying to beat back here? The thing is that any signal on this is heading towards amplification galore. So I make this wire very, very sensitive. The whole volume control, in fact, and everything connected to it. I didn't bother shielding any of this down here, though. So there's the resistor and the capacitor on the back. On the tab, can we read that? That looks like 0.205. What? Oh. 0.005. Oh, this is a nice schematic. You can read this clear as a bell. My gosh, my struggles are over. So we need to replace this. We'll check this. And we'll replace this. And I'll leave it outside a little can there. If it doesn't work out, I can always do something more with it. There are capacitors that you can get that have a built-in shield. They don't have this tube bolted to the chassis thing. They have 3 wires coming out of them, 2 capacitor wires and a shield. And any that I have are old and ruined anyway. So, but I've seen that in other radios. So I guess it's just highlighting the sensitivity of this part of the circuit here. All this. Okay, that's my first step. That's it. I've decided. Okay, 2 new capacitors in. This guy now. This is the antithesis of what they did with this. This is just out there. Hit me with your interference. We will see what happens. Okay, so alignment work. This kind of IF I have to get at from underneath also. So the radio has to be up on its side. Up we go. Get this antenna out of here. You want to see something really ominous. This is what ominous looks like for a Canadian. Winter boots are sitting there. Oh my gosh. What? Yes, it's coming. It's definitely coming. Now, do we really need that? We're going to end up playing the radio when we go to do the work anyway. So this has to go on the input side of the volume control. And this will be the pickup for the AVC voltage. Just shove it all over there. And now I got to set the signal generator up. Oh yeah, so where am I going to inject the signal? So we want to do the IF. We could try just blasting it in through the antenna. That's easy and often that's successful. Usually what they're recommending though is you put it right into the grid of the mixer tube. Some of these radios have circuits in them to catch the IF frequency at the antenna, so it doesn't come in and it doesn't go out the antenna. And that means trying to pump it in through this isn't the best idea, but let's give it a try because it's just so easy. And I like easy. Sometimes, if you're going to do something, it's like GPS in your car. GPS says go this way, but you'd really rather go that other route. And then when you finally decide, okay, let's go the other route, so you turn your car, the computer recalculates the trip, and you find out you've added 12 seconds to the trip. That's the decision point between going this way or that way. 12 seconds. It doesn't mean anything because that's 12 seconds based on speed limits, and that's not how you drive. It just goes to show you that these machines can make decisions that, in fact, it's a decision, but what are you talking about, Jim? I don't even know what I'm talking about anymore. Okay. Yeah. See, I got a little excited because I'm about to start the radio. Get a little excited. Kind of lose my head. Just like everybody. If you can keep your head when all those about you are losing theirs and blaming it on you. Greatest poem ever written. What am I waiting to do now? I'm not waiting to do anything. Turn on this equipment. Equipment's on. I'm really losing my mind here. Switch is off. We got to turn on the radio. The IF frequency is Kenneth. What's the frequency? 460. That would be like 459 on here. Perfect. 459. There it is. We want to put in a moderate signal. That's good. And we want it to be modulated at 1,000 hertz. So that's what we should hear come out of the radio. Yeah, we should actually hear it here, especially with my new capacitors up here. By the way, I checked that resistor. It was okay. There we go. Okay, dim bulbs doing the normal thing. I guess I need this meter on over here or it's not going to help us. So the voltage that's going to show up here is going to be negative relative to the chassis here. So I have the meter set so a negative reading is upscale. 15 volts, and you can see there's a touch of a negative reading there now. Let's just make absolutely sure it's real. Zero seems to wander on that meter. Five-volt scale, so it's barely producing a volt. Jumping around a bit, probably because it's picking up. Let's hear it. Let's hear it. It's picking up some noise. Okay, even with this connected, I'm going to tune the radio just to watch the ABC. Beautiful. Let's take it way down. That goes low. 640 Toronto. And let's look at the dial. I just said that. About 670 there. A strong tonal change as you advance the volume beyond a certain point. The treble shows up. Still something funny going on with this bass control. Treble is doing its job. Okay, we're good to go here. Let's find a quiet spot again. Terribly annoying way up here. Okay, that's as low as I'm going to get on the ABC meter. Now we're not hearing the signal generator, so either it's just not getting through the antenna, or this thing's not tuned to 460. Let me swing this around this way here. This is a bit of a listening thing. Okay, volume is up. Yep. Way up. Hey, hear that sound? That kind of high, I don't know what to call it, hummy sort of sound, higher pitched hummy sound. How much you want to bet it's that capacitor? But I got to hit the volume full for that to happen. To even back a little bit, you can't hear it anymore. Okay, that's good, I think. Let us now boost this guy up. I think I hear something now. I can hear it. Okay, we'll do a little tuning here. Not bad. Okay, let me just back this down again. I'm going to tune through it nice and steady. Actually, it's this way. Nice and steady. And we'll see if there's just kind of one nice peak here. There we go. One peak at about 465 is where it is. So we'll bring it down to where it should be. Should be there. Now if I blast even more signal in, maybe we'll hear it again. Perfect. Perfect. Now it's time to do some adjusting. So I'm going to do this with a metal screwdriver. As I've explained so many times, I find when you use the plastic alignment tools, they twist and they develop a spring charge in them from the twist, and then that releases and you get this popping effect as you try to tune these sticky things where they just pop, 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 pop. You need a stiff shafted screwdriver, a metal screwdriver. This is slug tuned, so I can't imagine this is going to have any effect. What will have an effect though is if I can't see clearly what I'm doing, the effect will be embarrassing. And so I get the volume up full, you can hear the hum. It's going to knock the hum back a little bit because I don't like it, and I'm going to increase the output here and back it off. About like that. It's not the sound, it's the ABC voltage that we're trying to track. Let me just double check this. I'm just going to tune the signal generator back and forth again. Oh no, I don't want to do that. Of course this is low because I've got this tuned off. Okay, I'm with it. So we want to start with the, normally you would start with the second transformer, that's this one. Bottom of the second. No change from tapping the slug. Here we go, watching the meter now. Very nice. There's just no doubt about that. I gotta get around the other side. It's a little awkward in here to do this. Okay. You can see the meter, so can I. Here we go. Now it looks like I'm peaking the radio up, and I'm actually moving the peak over, so I don't know that this is any stronger than it was. It's just the strength is in a different position. Let me check the bottom again. This is very nice. Those are like the nicest IF tuning I've ever done here. Now the other one, oh boy. So I cleverly installed this capacitor right in the way. Right in the way. Okay, I'll try and move it. Not recommended here. Not recommended. Let me try and move it with a tool. Also not recommended here. Nope. Yikes. I think the radio did something there when I moved that. Okay, I think I can get at the screw now. I can't see it. You hear that? This is having some effect. This has dropped to below 0, which I think is probably evidence that the clip fell off. That's what it is. The clip fell off. I want to make that sound and watch this meter again. Yeah, so when I contact it, you can see it is actually affecting it. Especially if I keep my beautiful coif out of view there. So we're going to need to use a non-metallic tool. The last one tuned so smoothly. So this is a very stiff one here, but I bet you I can't get it in the slot. I don't have to worry about this capacitor either. Oh yeah, it goes in. Okay, good. Now, watching the meter. Oh my gosh, you know what? Look at that. So that's why when I move the, I'm just pushing on it. When I move that capacitor, everything changed. Because of the mechanical forces and just moving things a fraction. Wow, okay, there's the peak. Okay, and now do the top one. Ooh. That's odd. This seemed to be in the right spot. How can it be in the right spot? So this is basically a preliminary alignment I'm doing right now, and I'm using a fairly crude but standard approach. I'm doing this whole thing with the radio on restricted voltage too. Let's correct that. Down on the signal strength coming up. Down on the volume, up on the voltage. Getting more and more AVC. It's not a tuning thing. It's just more of everything in here. Let's wait till it settles. So you can think everything went up. Plate, screen, bias. Okay, so I'm going to check first by swinging this frequency around and paying attention to the meter. But it just seems to be getting louder and louder. We don't need to hear it, really. Okay, watching the meter. So it's right on the money. So as expected, jacking up the input voltage to the radio doesn't do anything. For the alignment, again, this is just the preliminary run at it. That's it for the IF. So did we actually increase the strength of this radio? Probably did. But mostly what you heard was just me having the radio tuned in a spot and then bringing these things into that spot so you hear the signal come up. It can fool you into thinking you're making great improvements when you're not doing much. And why don't we listen to it right now? We'll just, that's easy. Swing this off the IF. Not that way though, let's go this way. Using this as my antenna. You know what? There's another capacitor in here I haven't dealt with yet, and that's this one. Don't worry about it. I'm bypassing it right now. More volume, I think. Give it a real McCoy antenna here. Oh, I see the ABC voltage is going great now. It's 15 volt scale. To 1 million. It's a million. We'll need it. 1 million. Oh, that's a lot nicer. So I'm just looking at the, taking out the antenna, hooking up the signal generator here. Wow. I thought I saw this meter go right over. Seems pretty good to me. More alignment is required for sure. Okay. No, I didn't read the instructions. I just went right ahead and boldly did that, all on my little lonesome. Well, we better read the instructions for the rest of it now. Thank you again, Jarrett, for sending me this. So here's the realignment details. Yeah, this is the one that just, the sentence just ends, unfortunately. Let's zoom in on this. What do you say? I'm going to read this whole thing here. Perform alignment in proper order as shown by the accompanying chart, starting with number 1. The accompanying chart. Oh. Okay. Chassis bottom shield must be securely in place when making RF adjustments. I just did some. Adjustment locations and frequencies shown on the sticker fastened to the bottom of the chassis shield. Is it? No, there's no sticker there. You liars. And just to help you out even further, these trimmer locations are also shown on the accompanying illustration. Luckily, here they are. They are here. There it is. Thank you. Connect. Oh, there's good instructions on here too. This might be enough to do it right here. I don't need written instructions, but let's see what else they say here. Connect the low output terminal of the test oscillator to the receiver chassis. Did that. Regulate the output of the test oscillator. Minimum signals applied to the receiver. I kind of sort of do that. This will avoid AVC action. Well, I'm using AVC action to judge the quality of my alignment. Preliminary alignment. The term dummy, yeah, I read this earlier, didn't I? The term dummy antenna means the device which must be connected between the high test oscillator output terminal and the point of connection to the receiver in order to obtain ideal alignment. So I have a standard dummy antenna, really a standard device. That's really what I should call it. Don't call it a dummy antenna, dummy. No signal 17 kilocycles means that the receiver should be tuned to approximately 17 kilocycles where there's no signal or interference being received from a station or the receiver oscillator. Where there's no signal or interference is received from a station or the receiver oscillator. Heterodyne. Okay, not quite sure what they mean by this. This basically, I do know roughly or generally what they mean. They mean tune the receiver to a quiet place. Don't stop right at 1700 if there's a signal there. The term in 1700, that's on the broadcast band. Often you're doing these alignment things. Well, this is for the broadcast band alignment, because often on these radios you start right at the top of the shortwave band. The term rock through indicates that the receiver station selector should be rocked back and forth. Receiver station selector, tuning control, should be rocked back and forth while making the indicated adjustment. The adjustment and rocking should be, we don't have the rest of what he says here. And this is a nice engineer writing that stuff. Drat. Well, we've got enough here to get through this, I'm sure. Where do we start? We would start with the broadcast band. Actually, if I get the broadcast band done, I think that's enough for today, really. So let's see what it says here. Meter BS. BS. Okay, BC oscillator trimmer. There it is. 1925 BC oscillator core. So this is 600. This is 1500. So this is probably a capacitor, and this is a this is right on their core. This is a coil. So we got those two. Now often we're doing these trimmers early on too. Broadcast RF trimmer 1500. So we're doing this one at 17 megahertz. We're doing this one at 1500. So now the question comes, do we start on that high shortwave band? And what about the magic eye? I still haven't even looked at it. Can you believe it? BC broadcast antenna trimmer, broadcast. What we'll do is we'll do the broadcast thing. We'll have to worry about this later. So it's 1, 2, none of these, none of that, none of those. 1, 2, 1, 2, 3, 4 things to adjust. Now the order would be, this is the oscillator here. These two things are oscillator adjustments. So we want to do the oscillator adjustments first, I think, and then we do the antenna adjustments. Antenna here and RF here. Probably doesn't really matter exactly what order you do these guys in, as long as you do them over and over. Oscillator. We'll do the oscillator first, and we need to find something out about the radio. Whoops. Where is the pointer in the right place? Okay, back to the radio. So chances are, yes, the pointer is on the string in the right place, because no one's ever moved it from the day they put it on there. Swing this around. Oh, it's still on, Jim. Still on, still on. Don't do something stupid here. Okay, now the story here is it has this screw, which if you loosen it, you can then rotate this ever so slightly. And the thing is, it's already rotated. I don't know if you can see it in the camera exactly, but it's not straight. It's tipped on an angle like this. Should I straighten this out? Did somebody do this on purpose? That's a pretty rugged fitting here. It's sliding on. Look, it's sliding on metal rods. So this is a pretty heavy-duty job here. That's for loosening it off the string. If I can get right around behind it here. So the string is right up on the top here. I can't see in the camera, I'm sure you can't either, so I'm just going to look with my own eyes. Actually, I need a mirror to do this. So it's a very simple clamp down on the string there. It's very simple, in fact. The string looks roughed up just to one side of where it's clamped, as if that's where it was clamped originally and it slipped. So let me try sliding it on the string here. So it's moving the whole mechanism. I hold it. So, you know, I'm not going to fool with that. It's on the string. If I fool with it enough, I'll be replacing the string, and I don't really want to do that. Now, is there some mark on the dial face here that shows like a registration mark of where the pointer should go? Let's put it all the way to one end. See what it does. I certainly don't see any marks. What I do see on here, because I cleaned this now, I've done a preliminary cleaning, and I very excitedly noticed small white specks of paint. So when you see small specks of paint on the radio, you know it's a real radio. It's had a real life. It's been in a room that somebody's painted. Just about every radio I do, somewhere has paint specks on it. Okay. Let's go to the other end and see if there's a registration mark down there. So we're not going anywhere near the same place. The closing of the capacitor, that's limiting it. Is there any extra little mark here? There's nothing. Okay, occasionally they put something right in the middle of the dial, but they very cleverly hide it from the ordinary person seeing it. But I don't see it. And then even an ordinary person, I don't see it. So another way is it equal balanced? Where does the pointer come relative to these lines? See, it's way out of balance. It was much further this way. But it's not exactly the same distance as this. It's actually a bit longer. You have to go over a little bit at each end. Okay, another way is we put the capacitor on a limit, and then we look in the manual here for this radio. I'm just going to do it myself and see if it doesn't declare its range. Somewhere it makes a statement. The range on this radio is. I'm looking quickly all over the schematic here. Trying to anyway. A range statement. Please just bear with me a moment. I'll dwell on this. No, not on that one. Let's try this other one. Other schematic page. Somewhere it would list the band or make a statement right on the schematic. Somewhere, yeah. So often there's promotional material that actually makes these statements. The bands are not listed anywhere. So what I was hoping there was it would say tunes from so-and-so to so-and-so, and then we can see if the dial pointer stops at those points. So we look at the broadcast band. It's like 1700. That's really the end of the band, and this thing's way out here. It's past the end on everything. Go to the other end of the band. it's almost lining up with the end of these bars, which could be the thing. We already know it's tuning incorrectly because it's picking up 640 up here. So I already notice maybe the pointer is too far this way. It looks like it's too far to the right. That would match with the damage on the string that I saw, as if the pointer has been forced over. On the other hand, you got to ask yourself, what are the chances, if this is the way it is and coming out of the factory, what are the chances that they got it wrong? Well, and I'm not sure how to proceed here, but we're sitting at what is basically 530 here. 530 is the very end of the AM band, so with the capacitor now it's completely closed. Is the radio really receiving 530? Well, why don't we ask that question? I just asked it. Why don't we find the answer? Did you hear it go by? I think I got the volume turned down here. So tuning 515, if you like, and really the radio is sitting on 536 or 535. We'll go to the other end and do the same kind of thing here. Hey, what happened there? So we're feeding the radio with 513 and it's picking it up again at double its frequency. Is that because of the radio? Or is that my signal generator? There it is again. Probably the third. So we're at the end now. The question is, what frequency is that? It looks like it should be 1850 or something like that. Nobody home? Turn the volume up a little higher. Well, that's really interesting. Look at that. 15. It's way in the wrong spot. So it's 15 way out there. But it's almost correct at the other end. Way out here. So, just thinking about from a different point of view, here in Ontario, the local, and there's no local AM stations to me, but the localist stations are all down at this end. So make sure this end is good, do my best on the other end. Then if I'm going to do anything with this radio, I'm going to listen to shortwave with it, and really it's the shortwave bands that would be of more interest, but here they come. I heard a kitty. Must be that time. So what we'll do is, we can set this right on the 550 mark. We'll do everything. Oh my gosh. There it is. The daily routine begins. Who's there? Who is that? It's the milkman. What do you want? Outside, do you? Okay. Now the cat's communicating to me by staying out of this room. He's telling me he wants me to come out with him. And where? Peanut. Peanut. Hey, Peanut. Yeah, where do you want to go? Show me where you want to go. Do you want to go out? Do you want to go to the garage? I think he said out. Okay, he's just gonna sit there and wait for me now. Okay, I'm gonna stop for a little bit. Go play with my cat. I'll just leave everything running here, and we'll just pick up in 20 minutes or so. So I've been staring away at this diagram for a little while, and finally I read the note here that says, alignment procedure. Perform operations in numerical order as indicated in brackets. Apply oscillator input to antenna terminal. That's just what I did. So, as indicated in brackets, so there's numbers here, like that's 7, 6, 4, la la la. Where's 1? So this is 1, 2, so I'm at 3 now. What is 3? I got 4 in here twice. Huh. Here's 3. Broadcast oscillators. This is 3, 4, and 4. 5. Well, there's another 4 here. 4, 4, and 4. Is there nothing at all is simple when you're doing this stuff? Everything is made just a little extra complicated. Dummy antenna for operations 1 and 2. 20 condenser, 20 resistor, 20 millifarad resistor. Come on, what are they trying to say here? Oh my gosh, that's got to be just a typo. Well, again, I'm using an international standard for the dummy antenna, the interface, the instrument interface with the radio antenna terminals. Okay, let's see what we're going to do here. 4, 4, and 4. Well, we know where 3 is. So we'll start here. We'll do this. Now, do I even want to do an oscillator? Do it at 600. I'll leave the oscillators alone for a minute. No, you know what? I can't decide what I'm going to do. I'm going to do this. We'll assume the pointer's in the right place. What else can I do? Stick this at 600, and we'll force it to receive 600 kilocycles at 600 on the dial. I'm just going to eyeball where that adjustment is. Make sure I've got it straight. Yep. Okay, here we go. Back to the radio. Okay, so the controls we're interested in are these ones. And we want to do it at 600. So I'll change my guy here to 600. Okay, so we got a 600 signal coming in. And we got to dial them up to 600 here. Where it's a little high. So making sure there's no parallax here. That's exactly 600 on there. And we're going to fiddle with the oscillator here. See if we can get something happening. Oh, turned it the right way. Watch the meter. Doesn't that sound nice and crunchy? Okay, so that's 600. Very good. That was easy. An awful lot of talk for something easy now. 4, 4, and 4 were these two trimmers up here and one down there. I'll put the diagram on my own screen here so I can see it. I know what to click here. So there's no order to the 4, 4, and 4. So one of the 4s is done at 1500. They're all done at 1500, in fact. So we must tune the radio up to 1500. Do the oscillator next to bring the 1500 in. That's got to be the way it works. The upper oscillator. That's 1500. Not sure why I was hesitant to do. I'm hesitant to do this because I don't know for sure the pointer's in the right spot. But what am I going to do? It's 1500. Where is it? It's way up here. Not so far. Okay, that's 1500 there. Now the oscillator control. I don't want to get these wrong. Is this one here? Outboard between those two things. Yep, no doubt about it. It's filthy dirty. And we got to keep our eye on that meter again. See if I can find it. Nope. Okay, so where is it? So I will tune the signal generator. What's happened here? Oh my gosh, look at the 13. Wow, I moved this thing a mile. Okay, so we're going to hopscotch our way back to 15. We're not going to get there. 1445 is where we're at right now. Dial's right on 1500. Well, we should go down to the other end because maybe the other end is kind of where the issue is now. Let me just come back here. You get the whole shooting match. Back down to 600. 600. Well, we're pretty much right on the money. So I got to try to move the whole thing between these two controls. Each one having a little bit of effect at the other end. So if we want to squeeze this end this way, it's going to move this end this way also. So we want this to be doing 600 just a little wee bit above. That's my theory. So we'll yeah, so I want 600. Yeah, I want to tune 600 here because I'm going to push it from the other end. That's my crazy thought on this. Do the inductor here. Don't even need a screwdriver. Good. A little bit of ABC action there. That's making it tricky. Now we'll go up the other end, which I don't think I've made much difference up here, but let's see. Well, that's a 600. 1500. Okay, 1500. Where are you coming in? Close. Still high. Okay, so I'm going to try to... I don't think I can do it. I think the capacitor is all the way to its limit. Let's see. The screw's going to fall right out in a moment. Close. You know, I've moved the 600 up. I would have moved this up also. Check the 600 and put it back the other way. Put it back to 600. Maybe we got there without me even knowing what I'm doing. It's great. Okay, 600 on the here. 600 here. I can't really get it any better. Didn't make much difference there. How sensitive is this end to this? I'm going to move the capacitor a little bit and watch what happens with the wrong end here. So it's moving it there a little bit. I'll put this more where it should be. Should be somewhere in about here. Now, where'd the 600 go? A little bit off. Okay, bring the 600 back here now. That's about it. Okay, did that help up here? 1500, that little bip is the image, I'm pretty sure. How close did we get this time? Oh, that's great. I should be able to push this up to 1500 now with the the bottom line is the capacitor has very little range and the slug has huge range. Okay, so now we turn the capacitor here. So this is fairly critical to get the whole radio to track. This has got three things tracking at once. So getting this right. Oops. Will help across the whole band. What happened to it? Where'd it go? How to get up there? I think I'm just confusing myself, that's all. I want it to go that way. Yeah. So again, the screw's ready to fall out. I don't think we're going to get much better than we are. It's pretty close. But what's important is what's happening down here. Make sure this is right on 600. You know what, the pointer is bent slightly. Oh, what have I? It's got a slight curve in it. Killing myself here. That's the peak, 606, right on 600. So we need to move this again, because we do want it accurate down here. There we go. Ooh. Look at this. If you push on it. I'm going to get the ABC out of the picture here. Same spot. Another thing I'm noticing, bottom of the pointer is standing fairly still, while the top is moving. Because of some angle change here. When the string tugs on the pointer, it's tipping the pointer a little bit. Funny that the bottom doesn't. Yeah, so really, how accurate can you get? can get that accurate. Next is what is next? Next is more 4s. So at 1500, so we go everything at 1500, or a quiet spot up here. That's a quiet spot. Now you can see the ABC voltage is on 0. So we'll max this in. This is a very low signal now, and the radio's receiving it quite well. No ABC action, just using my ear. Now we want to increase this. So I can just a little wee bit of ABC voltage. Let's just see if is that what that really is. Yep, perfect. Now what are we supposed to do at this point? We do 4, 4, and 4. So one is the antenna trimmer, one's the RF trimmer, and one, I already did the one. Did the one, 2 4s left. 2 4s. Get it right. These two guys, they're closer to the transformer. Yep. Okay, so this one. I still have not looked at the magic eye. Oh, it's right there in front of me and I haven't even looked at it. Okay, I'm looking at it. No wonder I haven't looked at it, there's nothing to see. Okay, watching the meter now. Oh. Okay, what's going on? Is that locked in place or something? I think I need a powerhouse screwdriver to start it off anyway. Try this one. Okay, watching the meter again. Oh. Wow. Okay, the signal is very low coming from the signal generator. It's really low. Okay, let's keep going. In fact, I really could have just... Never mind. Holy smokes. Wow, that's a huge bump up there. Now, the next one is this one here. Down. My gosh. Well, that was a huge difference. Let's see what we get for stations now. Have I left it? I've done this whole thing with a no signal generator on it. Let's take that off. Sensitivity on this radio appears to be sky high. Okay, antenna. $15 volts on the ABC meter now, 15 volt. Don't expect to hear anything. It could, if it's good, it'll pick something up at 840. Not that. Really, it's an antenna issue maybe more than anything. The radio can only produce what it's getting from the antenna. It allows the antenna Okay, we should start hearing 680. 640. Well, that's better than it's ever been.
You know, we're trying to kind of hold it together now. This is not the time to pick off the rest of the people on the plane. And I don't understand this.
You need to tweak those trimmers. We're at the other end of the band now. You need to tweak these two trimmers I just fiddled with.
Because we've only got really two major airlines left in Canada, you don't have a lot of choice. What I want is I get an idea. Next time I buy tickets with you, they're first class, and I'm paying for economy. How about that?
I'm sure, you know, and again with the airline industry, it's sad that this happens over and over, but this is how it goes. Some complaint comes, the airline comes out, apologizes, offers something. Well, why don't you just get it right the first time?
Yeah, one of the things I appreciate the call, Mark, that was really sad about this story is... Okay,
no advantage, they're just back where they were.
With two small children, but that's just children.
You know, that's not bad for the I just have a wire antenna on this. Another station is 590. About 585 on the pointer. .640 is about dead on 640.
Show me your ID, I'll see you in court on charges of harassment. And then yeah, but your old Paul, 2 years and older, yeah, but under, so that's
pretty muffly. Could be the speaker here, it's just the way it's facing. Yeah, a little better if I left it. Now, what I've noticed, for the first time, that's a pretty hot field coil on this. It's really pretty hot. Now, at the risk of calling my cat here, I'm gonna use this thermal gun, but it makes a beep. My cat always comes running because, you know why? Because it has a laser. And I played with him once with this, and he learned that beep means laser. Here we go. 46, 42, 44. 46 maximum. 50. That's higher than I would want. And the question would be, is that its temperature now, or is it going to keep going up? It's got a pretty good heat sink on it there. It's not frighteningly hot. Something to keep an eye on. Great. Okay, I think from here the next thing is more alignment on the other bands. We'll do the shortwave bands tomorrow, and then we'll have an overview of this whole radio at that point as to how well it's working. It's working pretty well, I think. So great. So thanks a lot for watching, and I hope you enjoy your day the way I'm going to enjoy mine. See ya.